Hi everyone and welcome back to yet another lecture of this series. So right now we are talking about the surface area and the BET technique which is used for measuring the surface area is based upon the adsorption of a gas on a solid surface. And with regard to that, we have discussed about different adsorption isotherms, and the isotherms which correspond to build-up of multilayers actually correlate to the BET technique, as we are going to discuss in this class.
So the BET theory is an extension of the Langmuir isotherm or the Langmuir adsorption theory, in the sense that the BET theory considers build-up of multilayers while the Langmuir adsorption theory talks about the formation of a monolayer. Okay. So now, considering the multilayer formation in case of the BET theory, the equation for the Langmuir isotherm can be modified accordingly to obtain the BET isotherm, and in doing so, the following assumptions are made. Gas molecules physically adsorbed on a solid in layers infinitely. Then the gas molecules interact only with adjacent layer, and the Langmuir theory can be applied to each layer. The enthalpy of adsorption for the first layer is constant and is greater than the second and also the higher layers. And finally, the enthalpy of adsorption for the second and the higher layers also is the same as the enthalpy for liquefaction. So with these assumptions, Langmuir isotherm can be modified as follows to obtain the BET isotherm. Where P is the partial pressure of the gas, W is the amount of gas adsorbed at pressure P, P naught is the saturation pressure of the gas, and Wm is the amount of gas adsorbed corresponding to formation of a monolayer, and this is also known as the monolayer capacity. Okay, so from this equation you can see that if you plot this with the relative pressure P by P naught, it will give rise to a straight line. The slope of which is C minus 1 by WMC, and the intercept is 1 by WMC. Here C is the BT constant, and this is given by the following expression. Exponential EM minus EL by RT, where EM and EL are the heat of adsorption for the first layer and the successive layers respectively. And R is the gas constant and T is the absolute temperature. If you add the slope plus the intercept, this is what is obtained. Therefore, Wm is simply the reciprocal of slope plus intercept. Okay, so that's how you can obtain the monolayer capacity from this equation by plotting it between these two parameters, which gives rise to a straight line.
So now that we have understood the basic principle behind the BET technique, it is time for us to look at the BET instrument and the actual measurement methods.
So in this BET technique, or the gas adsorption technique of measuring surface area, a clean powder surface is basically exposed to varying partial pressure of a known gas, the adsorbate gas, and the amount of gas adsorbed on the powder surface is measured. So what we need to obtain from here is the mass adsorbed at saturation when the monolayer is formed, right? So this is what we are looking for, Wm, and just now we have seen how it is related to the partial pressure of the gas or the relative pressure. And in order to determine this, there are various methods which can be used in this gas adsorption technique, and these are as follows. The mass adsorbed can be determined by the pressure drop, which is kind of measuring the volume of gas before and after the adsorption has happened, and hence known as a volumetric method. The weight gain of the powder due to the adsorption can also be determined to get to know about the monolayer capacity Wm. So this method is known as the gravimetric method, as it is based upon the weight gain which is being measured. And apart from that, the thermal conductivity change due to the absorption can also be measured, and from that the amount of gas that is adsorbed can be calculated, and this particular method goes by the name dynamic flow. Okay, so these are the different methods which can be used in the gas adsorption technique to measure the amount of gas that is being adsorbed at the saturation when the monolayer is formed. And if you look at the instrument which is being used for this is a schematic of the same. Here you can see the very basic parts of the instrument. So as I said before, a clean powder surface has to be presented for this adsorption to happen, and therefore the first thing which is done in this technique is to clean the powder, and in order to do that it has to be degassed to remove any adsorbed gas or vapor which may be physically or chemically adsorbed on the surface of the powder, right? So the first step is degassing, and that can be done under vacuum at high temperature, and the temperature which can be used to do this degassing can be determined either by thermogravimetric analysis TGA or differential scanning calorimetry DSC. TGA will simply give you the mass loss of a powder sample as you heat it. So it will show up to what temperature the mass loss is happening. That means all the adsorbed gas and the moisture is being removed. So from that we can determine as to what temperature the powder sample has to be heated for the degassing to take place, and if there are chances of any phase changes, then DSC analysis can also be performed in order to know that what is the temperature or the temperature range in which a different phase might form, and therefore that temperature has to be avoided during degassing of the sample. And most of the modern instruments have a degassing chamber as an integrated part of the instrument itself. So before the sample is loaded in the sample chamber, it is first sent to the degassing chamber, degassed, cleaned, and then cooled down, and after that it is sent to the sample chamber where it is exposed to a liquid nitrogen bath to keep the sample at very low temperature, because nitrogen is generally used as the adsorbate gas and it has to be used at its boiling point, which is 77 Kelvin, and therefore the sample is cooled down by bringing the liquid bath to the sample tube. So the sample tube, if you see, it is basically a tube with a bulb at the end, something like this. The design of this bulb may be different depending on the type of sample, but basically this is what it is. It has a tube like this, and then at the end there is a bulb. So the sample is loaded and kind of kept in this bulb, and this sample tube has to be exposed to the cooling bath, which is basically liquid nitrogen. So after the sample tube is loaded to the sample chamber, this cooling bath is brought in contact with the sample tube and it is cooled down, and after that the adsorbate gas, which is generally nitrogen, as I said, is passed through the sample at a known pressure, and the amount which is adsorbed when the monolayer forms can be determined by the three different techniques as we talked about before, and from that the specific surface area can be calculated. Okay, and apart from nitrogen, other gases also can be used. For example, krypton at liquid nitrogen temperature can be used for materials having low specific surface area in the range of less than 0.2 meter square per gram. And now once the Wm, or the amount adsorbed corresponding to the monolayer formation, is obtained from this measurement, the specific surface area can be obtained from this equation. Where AS is the specific surface area, Na is Avogadro's number, A naught is the average occupational area of a gas molecule. M is the molecular weight of the gas which is being used as the adsorbate. And M is the sample weight. And therefore it is also necessary to measure the sample weight before the surface area measurement is started, and it has to be done carefully because most of the time the amount which is being absorbed is very small, particularly if you are using the gravimetric method, which is based upon the weight change after the adsorption. Since that weight change is very small, this measurement of the sample weight has to be done very carefully. And in order to calculate the specific surface area from this particular equation, this property of the gas, the occupational area has to be known, and that is why a known gas is used so that this can be easily obtained. So these three methods that I mentioned will be discussed one by one separately, and we'll see how each of these methods are performed to obtain this amount adsorbed for the saturation. So let's talk about the volumetric method first. In this technique, the volume of the gas during the adsorption is directly measured, and in order to measure the gas adsorbed, first the dead volume, that is the void space around the sample, is measured. So once the sample is degassed and dried and it is loaded into the sample chamber, first whatever volume is left around the sample, which is known as the dead volume, that is first measured. And this is the volume which is used to actually calculate the adsorbed gas by the difference of this volume and the actual amount of gas which is being admitted into the sample chamber. And in order to measure this dead volume, helium gas is generally used because helium exhibits negligible adsorption on solid surfaces. So as I said, the amount of gas which is adsorbed is given as the difference of volume of gas which is actually admitted into the sample chamber and the dead volume. Okay. So from this difference, the amount which is actually adsorbed onto the sample surface can be calculated. And in order to generate different relative pressure to plot the isotherm, the pressure can be varied, and in each case the amount of gas that is being adsorbed is calculated by this difference method. And the generally used range for this measurement in terms of the relative pressure is from 5 to 35%, which is basically the linear range or the monolayer coverage region of the isotherm. In the gravimetric method, the weight of gas adsorbed is measured, and in this case, since the amount of gas adsorbed is very small, a very sensitive microbalance has to be used, and these kind of balances can measure weight differences in the range of nanograms to milligrams, right? So it has to be that sensitive because of the fact that the adsorbed amount is actually very small. So in this case, what is done is that the sample is exposed to the adsorbed gas at a certain pressure, and a certain time is allowed for the equilibrium to establish, and then the mass change is measured as the gas is adsorbed onto the surface of the powder particles. And the experiment is repeated a number of times at different pressures to generate different relative pressures and to plot the isotherm. In the dynamic flow method, a parameter such as the thermal conductivity is used. Basically, the change in the thermal conductivity due to the adsorption process is monitored in this case. The adsorbed gas is flowed at a known rate through the thermal conductivity cell. So here, apart from the sample cell, there is a thermal conductivity cell also through which the gas will be flowed. And if there is any change in the thermal conductivity of the gas, that can be captured by this thermal conductivity sensor, which is there in the conductivity cell. Now, after being passed through the sample, the gas is again flown through a thermal conductivity cell. This is to check, if there is a change in the thermal conductivity, as I said. So if there is adsorption of the gas on the solid surface, there will be some imbalance into the amount of gas which is flown into the conductivity cell, and therefore, there will be a change in the thermal conductivity, and that is how the change in the thermal conductivity can be correlated to the amount of gas which is adsorbed on the solid surface in the sample chamber. This thermal conductivity change is fed through a pulse into the system to generate the signal, and the pulse which is fed is actually proportional to the amount of gas adsorbed, and that is how the amount of gas adsorbed at different pressures can be calculated from this, and the isotherm can be plotted. So this was all about the BET surface area measurement technique. Now there is one more method which can be used to measure the surface area of powder. This is the gas permeability method. This technique is based on the dependence of permeability of a gas flowing through a porous column of bed on the surface area. Right, so from this dependence of the surface area onto the permeability, the surface area of the powder can be calculated. So what is done here is a cylinder of packed powder, which you can see over here, is first made, and this is then exposed to a known flow rate of a gas, and the pressure drop across it is measured. Okay, and from that the permeability is determined using Darcy's equation, which is this one, where Q is the flow rate of the gas, delta P is the pressure drop that is actually measured, alpha is the permeability, L is the distance through which the gas flows or the sample length, A is the cross-sectional area of the sample, and eta is the viscosity of the gas. Okay, so once this alpha is obtained from this equation, it is used here in another equation known as the Kozeny-Kármán equation to calculate the surface area S. Okay, and in this equation, this epsilon is the porosity of the powder compact, which can be measured beforehand, and rho m is the theoretical density of the material. Okay, so this, before we finish this lecture, let us take a moment to summarize it. So today we talked about the BET theory and its application in measuring specific surface area. So the BET theory is basically an extension of the Langmuir gas adsorption theory or the Langmuir isotherm, which considers formation of a monolayer, whereas the BET theory considers formation of multilayers with the assumption that for each of the layer the Langmuir theory can be applied. And considering this multilayer adsorption, the Langmuir isotherm is accordingly modified to obtain the BET isotherm, and from there we can obtain the specific surface area of a powder. And in order to do that, all you need to do is basically measure this monolayer capacity, or the amount of gas which is adsorbed at the monolayer coverage. And once it is obtained, the specific surface area can be obtained using this particular equation. Okay, this we have already discussed. And in order to measure this WM by that gas adsorption technique, there are various methods. Primarily, three methods can be used to do this, and those are the volumetric method, where the volume of the gas is directly measured, the gravimetric method, which deals with the weight change as a result of the adsorption, and this amount can also be measured indirectly by measuring a change of a particular quantity, for example the thermal conductivity. So those kind of techniques are known as the dynamic flow technique, in which the gas is continuously passed over the sample, and as it is being adsorbed, there will be a change in a particular property, for example the thermal conductivity, which is being monitored, and from that change the amount which is being adsorbed can be calculated. Okay, so these are the methods for measuring the surface area of powders using the BET technique.
So with that, we come to the end of this particular class, but I am going to see you soon again. Thank you for your attention.